Today, we are going to be solving a problem that was created by, you guessed it, an 8th grader. This 8th grader calls himself online as Math645, and he managed to write a pretty interesting problem on the product of cosines. Basically, he asks us to rewrite this product of cosines, cosine of pi over 2 squared, cosine of pi over 2 cubed, on until cosine of pi over 2 to the 10th, and to rewrite it in the form of a secant of bx, where a and b are constants. Yeah, so pretty much as I'm editing this video, I realized that I made a mistake in the problem statement. It's supposed to be a secant of b pi, not bx, and I'm sorry for doing this to you guys. Thank you. And in this video, I will be showing you how to solve it. Before we get started, make sure you leave a like, subscribe to my channel, and let's get on with the solution. We first noticed a pattern that is going on with the angles. And looking at the second cosine, we see that we're taking the cosine of pi over 2 cubed, and pi over 2 cubed is half of pi over 2 squared. So in succeeding terms, we're just multiplying the angle by 1/2. And the pattern keeps going until we get to pi over 2 to the 10th. Another way to look at this is if we look at the first term first, it's pi over 2 squared. And we know that pi over 2 squared is 2 times pi over 2 cubed. So the first term is actually double the second term. And this pattern will keep on going until we get to pi over 2 to the 10th, right? So we're multiplying by 2 each time. This observation makes us think of both the double angle formulas and the half angle formulas for cosine. And so we might think, how can we use these formulas in order to rewrite our product as this very simple a secant bx? Using either one of these formulas might get us to be able to rewrite the product in terms of just cosine of pi over 2 squared or cosine of pi over 2 to the 10th. But the thing is, because the formulas are so complicated, we have that squared of the cosine term in the double angle formula, right? And then we have that plus or minus the square root in the half angle formula for cosine. Using these identities won't get us anywhere near a secant bx because there's no power in this secant bx, right? There's no 2 and there's no square root, right? So we need to think just a tiny bit smarter, but we're pretty close. The right idea is to actually think about the sine double angle formula. This is because the powers in the sine double angle formula, they're all 1, right? And the reason we can't use the sine half angle formula is because we still have that plus or minus and we still have that complicated square root that makes everything harder. So now the question is, how can we use the sine double angle formula in order to rewrite a product of cosines? But anyways, let's actually start writing down stuff, okay? We're going to let p be our product. And I'm actually going to switch around these terms to make things look a little easier. I'm going to let p be our product, and it's going to equal cosine of pi over 2 to the 10th times, okay, that's pretty cool. So now we try to experiment. What if we multiply both sides by 2 sine of pi over 2 to the 10th? This would give that 2 times sine of pi over 2 to the 10th times p is equal to 2 sine of pi over 2 to the 10th times cosine of pi over 2 to the 10th times cosine of pi over 2 to the 9th times dot dot dot, right? And then, this cosine of pi over 2 squared will come down. Notice that we can use our double angle formula right here. And this will just turn into sine of pi over 2 to the 9th. This is promising because if we continue with the rest of the terms, we have sine of pi over 2 to the 9th times cosine of pi over 2 to the 9th times cosine of pi over 2 to the 8th times dot dot dot, right? And then we're going to get to cosine of pi over 2 squared. But notice how similar this is to our double angle formula, right? If only we just had another 2 here, we could use the double angle formula again. And we could really just keep going with this. What if we increase that power of 2 that we multiplied by up to, say, 2 to the power of 3?
We're going to get that 2 cubed.
Yeah, so this video is getting a little long. Basically, we just apply the sine double angle formula a couple times, and then it simplifies to the thing at the end. And so what we notice is that the higher power of 2 that this term right here is going to be, the power of 2 that we multiply both sides by, the more the product is going to collapse like a telescope, right? This is called telescoping. And so the question is, what power of 2 should we multiply by in order to simplify the expression as much as possible? With a little bit of thinking, we'll find out that the answer to this question is actually 2 to the 9th because we have 9 cosine terms right here. If we multiply both sides by 2 to the 9th times sine of pi over 2 to the 10th, we're going to get that 2 to the 9th sine of pi over 2 to the 10th times our p is going to equal our 2 to the 9th sine of pi over 2 to the 10th times the rest of this stuff, right? Dot, dot, dot. What we end up seeing is if you do all those steps, right? If you do all the steps of applying the double angle formula over and over again for sine, we're going to get that the product on the right is going to equal sine of pi over 2, which is double the angle of sine of pi over 2 squared. And obviously the sine of pi over 2 is just 1. It's at the top of the unit circle. So this is equal to 1, right? And so dividing by this constant next to the p, we see that p is equal to 1 over 2 to the 9th times sine of pi over 2 to the 10th. Oh wait, but remember that we're trying to write this as a secant of bx. And isn't 1 over sine just secant x? No, the answer is no. 1 over sine x is actually just cosecant x. Please remember that. And so we can rewrite our sine in terms of a cosine. Yeah, so we can pretty easily fix this by remembering that, note that the sine theta is equal to the cosine of pi over 2 minus theta. Using this will give that the sine of pi over 2 to the 10th is going to equal cosine of pi over 2 minus pi over 2 to the 10th. And so let's do a little bit of arithmetic to simplify this. We're going to get the cosine of 2 to the 9th pi over 2 to the 10th minus pi over 2 to the 10th. This is equal to the cosine of 512 pi over 1024 minus pi over 1024, which equals cosine of 511 pi over 1024. And so putting this back into our p, we're going to get that p is equal to 1 over 2 to the 9th times the secant of 511 pi over 1024. And so we are done. Thank you for watching the video. If you have any suggestions or critiques of my solution, please feel free to leave it in the comments. If you enjoyed this video, please make sure you like and subscribe, and I'll see you next time. Peace out.